Good day and welcome to another Micrographics webinar. We are an Autodesk partner and reseller. My name is Sean Bauer and I will be presenting this webinar today on the 18th of September 2025. I am an application engineer and an Autodesk AEC technical consultant with Micrographics. And today's topic is Designing a Better Future, Sustainability and Collaboration with the AEC Collection. If you find this webinar to be informative, please like this video and subscribe to our channel for future webinars. Okay, so let's get into it. On the agenda for today, we'll have an introduction for the webinar. We'll have early stage sustainability with Forma, detailed design with Revit and Insight, BIM Collaborate Pro for cloud collaboration, sustainable design in action, and then a conclusion with regards to all of the above. On the introduction, whether you're an architect, BIM coordinator, or sustainability consultant, we all feel the pressure of tighter timelines, stricter sustainability targets, and complex multidisciplinary teams. In this session, we'll explore how the Autodesk AEC collection empowers smarter design through real-time collaboration, early insights, and powerful analytics, all within one ecosystem. So the world is changing, right? Let's face the facts. The days of sketching by hand, communicating via emails and in-person meetings, printing documentation, making hand sketch corrections are all in the past. With rapid urbanization, climate urgency, and growing client expectations demanding a new approach to design, how do we keep up with this? We need smarter and faster and greener designs. Today's architectural projects must be efficient, environmentally friendly or responsible, and highly collaborative. Teams need alignment. We have disconnected workflows, hand sketches being scanned and emailed or sent by post. And this is all within then siloed data. Printing papers increases the risk of delays, errors, and sustainability blind spots. So we'll enter the AEC collection. The Autodesk AEC collection offers an integrated ecosystem to support sustainable high-performance design from concept to construction. So in the introduction, sustainability. Regulations and clients demand low carbon, energy efficient and resilient designs. Speed. Tight schedules, rapid iteration cycles, and fast-track construction increase the pressure to deliver faster. Team alignment. Multidisciplinary teams often work across time zones and platforms, creating silos and risk. As stated by the World Green Building Council, over 40% of global carbon emissions come from buildings and construction. So why do we need smarter architecture today? Because the demands on architects, engineers, and project teams have never been higher. First, sustainability is no longer optional, it's a mandate. Whether you're targeting net zero buildings or simply complying with new energy codes, such as the SANS 10400XA or other SANS codes, we must reduce our carbon footprint. Second, there is speed. Projects are moving faster. We need to design, analyze, iterate, and deliver in weeks, not months. And third, team alignment. With teams spread across offices, disciplines, and time zones, we must overcome disconnection. Tools that unify workflows and provide a single source of truth are critical to avoiding rework, clashes, and delays. So how do we achieve a sustainable design and workflow that allows to meet these tighter deadlines, collaborating over time zones? Early stage sustainability with Forma. So a project would start in Forma, where you would analyze the environment and the environmental impacts from the earliest stages. optimizing natural light in and around buildings isn't just energy efficiency, it's about creating spaces that enhance well-being, boost productivity, and reduce environmental impact. Sustainability and environmental analysis with Forma. The key sustainability features in Forma would include solar, sun hours, and shadow studies. Looking at the sun hour analysis, for example, with the very handy function to place spot temperatures. Daylight potential analysis with the vertical sky component scores, giving insight to how much sunlight reaches the facades from the sky and shadow studies. An all-encompassing solar study can be generated to optimize your building's orientation. Identify optimal facade designs for natural lighting and energy efficiency. The wind analysis. It uses computational fluid dynamics, CFD, based simulations to study wind behavior around buildings. Optimize the site and massing to improve ventilation and reduce wind turbulence. Assess the effects of wind on the site. View the impact at certain heights and angles or by importance. With additional statistics, you can view the ground and or roof conditions for comfort level and the wind direction in height or with importance to the structure and the surrounding area. This is an invaluable tool to optimize sustainable and environmentally friendly designs. The microclimate analysis in Autodesk Forma enables designers and planners to evaluate the thermal comfort of outdoor spaces early in the design process. It provides a detailed, feels-like temperature map of your site by combining data on sun exposure, wind patterns, and sky visibility with your local weather and climate data. The key features would include the Universal Thermal Climate Index, a globally recognized and accurate measure used to represent outdoor thermal comfort. Data sources. It utilizes the ERA5 dataset from the Copernicus Climate Change Service for climate information, example the solar radiation or the cloud cover, and wind roses from the Global Wind Atlas. Visualization. It generates an intuitive microclimate map, making it easy to identify hot and cold zones and improve outdoor livability. So taking a look at sun hours, this is within Forma, how one would run an analysis. Select your dates by month and day. Allowing you to look throughout the year what the sun hours and the effects of the suns on your facades, roof and ground conditions would be. We'd run an analysis. Okay, let's see what the results are. This is within Cape Town. We chose a specific day, and then you have a time interval that you can select. From what time to what time, and then the direct sun on ground, meter squared. You can inspect how many hours of sun you get at specific areas within your building or around your building. Then we have the handy inspect tool, which gives you the opportunity to see how many hours there are based on specific points on your building. So seeing that there are certain areas that get no sunlight during specific time of the day, one could make design iterations to allow for natural sunlight, reducing the need for artificial lighting, considering that there are indoor spaces that need to be well lit. Then we have our wind analysis. You have your comfort levels and the direction that the wind comes from. You have the different comfort scales. You have your ground temperatures and your roof temperatures. considering a southeast wind, which is quite common in the Western Cape, especially Cape Town. You can view it by height or by importance or by variation, and you can see how it would impact the different levels of your structure, what kind of wind strength one can expect. This is based on the local weathering data from Cape Town. So that's for visual effect, so you can see the impact visually. And this can be shared to all team members via your Autodesk Construction Cloud, or you can export the data and share it with them as a CSV file. Then we have the microclimate. Overall, this analysis helps you design a more comfortable, sustainable, and climate-resilient urban environments with data-driven insights into the thermal performance. So the microclimate would be a combination of air temperature, sun hours, and wind. Choose the time of day, month, and see the interaction surrounding your structure, understanding what the comfort levels are, and you can view all the statistics and also confirm the Copernicus ERI5 data source where the information comes from regarding your site. And you can use the handy inspect tool to get clear indication of what temperatures would be like. This would be in winter in Cape Town, maybe mid-summer. It would be a good idea to also know what kind of temperatures to be expected, how much mechanical ventilation, air conditioning, and ductwork will be required for comfortable conditions, livability. So why start in Forma before designing? Understand the site first. Analyze the wind, the sun, the shadows, and the microclimate before sketching a design. Smarter orientation and placement. Shape your building to maximize comfort and livability. Informed decisions early. Compare scenarios and avoid costly rework later. From vision to viability. Early insights guide sustainable, people-centered design. For a sustainable design. So as an overview of Forma, in Forma you can create your own site, you have a board where you can compare things and collaboratively work with others. It's a whiteboard space. Here is your projects. This is the homepage of Forma, the hubs that you've joined, companies that you work with, and your designs that have been created, your proposals. So with Forma, you have your site to design, you have the board where everybody can talk and share information and insights, and you can compare your different analyses. Here you can add your members, you can see who is a part of this project. Right, and there are all the different types of analyses that one could do, from noise to solar to embodied carbon to shadow studies. You can also add additional extensions for additional analysis types. So I, for example, have a parking calculator to create parking areas, and for aerial map information, and for more site-driven information. You can control how the shadows are displayed if you want to share this as an image with others. You will also notice the area matrix on the right hand side with your structure. It's giving you insight towards how much ground floor area you're using, internal and external gross and net area. You can have multiple proposals, add new proposals if you want to make design iterations, and run different types of analyses to see how, if you make changes to your design, what the impact would be with regards to all the different types of analyses. When you do shadow studies, you have quite a lot of settings that one could change. Your day, month, and the time. Whether you want to see it every 5 minutes, 15, 30 minutes, an hour, or every second hour to see how the shadows would interact with your structure and surrounding area, or even the building next door, how the shadows would fall onto your site. If you want to see it clearer, you can turn the geometry to be white so that the shadows are easier to see. So you have the preview function, and then you also have the option to export it as images. All of these different views as they display, which can be shared with others. Embodied carbon, and also you can go learn more about the embodied carbon if this is something that you would like to analyze additionally. And you can decide what within the model you would like to analyze with regards to the envelope of the structure, the entire structure, the structural elements, interior, or the MEP systems. And then you can run an analysis with regards to the carbon footprint. So I previously run one, so I'll compare it just to show what it looks like. So on the top left, you'll see it says Forma compare. You're able to compare proposals and then different analyses with each other. You can also view them side by side. So there, for example, we have our solar energy analysis and our carbon insights on the left. By right-clicking, you can add more views, either split the view horizontally or vertically. So here we now have the sun, wind, microclimate, and solar energies to compare them with each other to see what the effect would be. So that would be my Revit model that I imported, and I can see that how comfortable it would be. Certain day of the year, so the 10th of September, I would have 9.5 hours of sunlight on there. I would accumulate 1,504 kilowatt hour per square meter if I had solar panels on my roof, what the wind conditions would be like, and what the temperatures would be like. Knowing what the conditions are like, you can also determine which space you would like to have where. Do you want a sunroom for the house? Do you want a braai area? You can determine what needs to be placed where for best orientation. Maybe tilting the building ever so slightly, I might get more sun hours for more solar energy for my solar panels to generate more electricity. Understanding the wind speeds can determine the roof pitch. So understanding your site before you start designing is ideal. Knowing what the conditions are like. Okay, so as you can see here, before I even place the first wall, you do have the option to do just a generic mass within Forma. So even if it's just a square block, or if you want it based on a house design or a commercial structure, depending on your needs, you are able to create massing elements in here. And this, once your mass has been created, can be sent to Revit, and within the Massing and Site tab, you will find the Forma panel where you can load the proposal, which is quite ideal if you would like to have a generic understanding of your contours of your site, how it falls, what it looks like. Now you understand the conditions of the site with regards to all the different analyses that were run. You have your structure available. When you import the model, I've hidden all the other ones that I am not using, so the surrounding structures. but then you can start making design iterations. So the massing elements that you bring in from Forma can be converted in Revit to become walls, floors, roofs, etc. So here, for example, I can convert the walls. I did this before the webinar, just to show what one could do. I converted them into glazing elements. I tilted the pitch of the roof. And once you've done your design iteration, send it back to Forma, rerun the analyses, and see if your design iteration made a difference with regards to all the different analyses that are available. So I've hidden the level lines, but there are levels that are created and given to you within Forma. Okay, so that's my site, my topo solid. I can also go and crop just that area out if I do not need all of the other information. As you can see, it becomes a roof element, and the roof element can be altered. So there you have, it comes in as a wall by Forma, and you can convert that into your own elements, making it usable Revit elements. So it's a fairly big site that I brought in, which is why my computer struggles to keep up, but it's quite ideal how quickly one could make adjustments in Forma, from Forma to Revit. Alright, so from Forma to Revit for the detailed design, including the insights, Autodesk's commitment to a sustainable future. Autodesk has made sustainability a core pillar of its mission. With every software update, they continue to enhance tools to support low carbon, energy efficient, and environmentally responsible buildings. Revit empowers architects and engineers with a wide range of built-in and extensible analysis tools that support green and high-performance design. The built-in analyses include energy modeling, lighting and solar studies, HVAC and MEP systems, structural performance and analysis, carbon analysis, electrical load calculations, routine and space utilization, just to mention a few. Additional extensions are available via the Autodesk App Store, and Autodesk Construction Cloud integrations expand these capabilities even further, allowing for a deeper lifecycle assessment, advanced simulation, and carbon tracking. Together with the cloud collaboration and AI-driven design optimization, Autodesk Revit helps project teams align with global sustainability goals, reducing both operational and embodied carbon while designing for a net zero future. So, detailed design in Revit. When most people think of Autodesk Revit, they immediately connect it with 3D modeling, coordination, and building information modeling, BIM. While those are its core strengths, Revit is also a robust platform for producing detailed 2D construction documentation. Many architects and engineers assume that AutoCAD or other drafting tools are still needed for detailed drawings, but Revit offers a complete set of tools to create elevations, sections, wall details, stair details, floor assemblies, and more, all within a coordinated BIM environment. So we will look at the different types of views that are available in Revit, the functions that support detailing, and how Revit can be leveraged to produce documentation suitable for municipal approval and construction teams on site. So Revit for detailed design. the key benefits when detailing in Revit. First, why detailing in Revit matters. Detailing is the bridge between design intent and construction execution. Without precise details, contractors and builders cannot interpret the architect's or engineer's vision. Revit brings detailing into the same environment as the building model, eliminating the risk of disconnected CAD files or manual rework. So the key benefits within Revit would be the coordination. All the details are tied to the model. When the model changes, the detail views can be updated quickly. The accuracy with regards to dimensions, tags, and annotations, which pulls real data from the model, is ideal. Consistency. View templates, detail components, and annotation types enforce company standards. Productivity. Revit allows for both model-based details, which are generated from sections and elevations of the model, and drafting-based details, created with symbolic lines and detailed components. Complete documentation. From schematic sections to municipal submission details, everything can live in one environment. So the different types of detailing views that are available within Revit include floor plans. These are horizontal cut views through buildings. It's from the level of detail would be coarse to fine, and use cases, general layouts, floor assembly finishes, fire ratings. Seating plans is views from above or from below looking up towards the ceiling. Medium to fine detail, this would be for MEP coordination, ceiling finishes, lighting layouts, and so on. Elevations, vertical projection views, medium to fine level of detail. Exterior finishes, facade details, and wall build-ups. Additionally, you can also have internal elevations. Sections, cut through slices of the building with fine detail. It includes wall sections, stair sections, and foundation details, just to mention a few types. Callouts, that is a zoom in detail of larger views. Fine detail, this would be for window details, wall junctions, or roof connections. Drafting views, independent 2D detailed drawings with fine level of detail. Typical details, manufacturer details, or standard notes. Detailed views is enlarged detail-rich callouts at fine level of detail. It's floor to wall junctions, waterproofing, insulation details. And then you get 3D detail. Isometric or perspective views, coarse to fine level of detail. Complex connections, exploded axonometric details for contractors. Here are some examples, what they look like, the different types of detailing that one could get. Functions and tools for detailing in Revit. While views are important, the real power lies in the detailing tools that Revit provides. The tools will include detailed components, line work tools, filled regions, also known as hash patterns, detail lines, tags and annotations, keynotes and keynote legends, detailed groups, drafting views, which is similar to AutoCAD in Revit. You have the same modification and draw tools as you have within AutoCAD 2D annotation and drafting, view templates and filters, and detailing in Revit. When you detail in Revit, you can add annotations, dimensions, 3D multi-leaders, and generic text. They can all be placed within 3D. If you make a change to an element with regards to its material, its size, a tag can automatically update on all the views. So looking at an example of using this within Revit, here we have our different views in our project browser. Floor plans to 3D views, elevations, sections, detail views, renderings, drafting views, walkthroughs, area plans, legends, schedules, a multitude of different view types. You can also create your own types. These are typical examples of cut-through 3D geometry to have as detailed views, which you would annotate or tag different types of elements. Then you have the AutoCAD to Revit drafting views. You could import or link AutoCAD files, or you're able to draw them in Revit from scratch, creating all the different types. If I take an example, here is my drawing in AutoCAD. We have our line tool, our drawing tools, and our modification tools. Those are also available in Revit. Same with the annotations. So how would one do it? Go to your View tab, select the drafting view. This is to create those 2D detailing elements with detailed lines, detailed regions, components, installation, and more. Give it a name. I'll just call it a webinar example. Select your scale that you want to work with. Draw on. Can be altered after. You can link a CAD or start without a CAD drawing. Your AutoCAD is available inside Revit. And on the Annotate tab, you will find all the 2D elements that one could use within Revit, including symbols, keynotes, tags, text, multi-leaders, and detailed lines and dimensioning. For a quick sketch, if it is a PDF, vector PDF, or a CAD file, you can quickly just trace it with the pickline tool. And in a matter of seconds, you have your drawing drafted with Revit elements. Then you're able to have a filled region or a hatch pattern for more visual or graphic understanding of what the element is, that it's been cut through, or however you'd like to communicate your work. These hatch patterns, you also have the same hatch patterns available as you have in AutoCAD. If you edit the type of the filled region, you will find the full pattern. So here you can see all the preloaded ones within your template. You can create new ones or load other ones if you have them already available, but then you also have 3D model full patterns. You can give it a color as well to define the information more clearly visually. Then once the lines have been done and the hatching has been done, you also have the opportunity to dimension this. You have the same dimension tools as you have in AutoCAD: the line, linear, angular, radial, diameter, arc length, spot elevation, spot coordinates, and spot slope, which can also be used in 3D. You can add a prefix and suffix, change the dimension style for different font or size, and you quickly have everything that you need for your detailing. Then there are great tools such as the detailed components. Instead of drawing all of this with polylines or rectangles and then hatching them, with a single click you can place an entire wall ready for a foundation detail or wall detail. So apart from the detailing capabilities in 2D and 3D, Revit also offers analysis tools, simulation tools, scheduling, legends, and more catered to architecture, structural, mechanical, electrical engineering, HVAC and plumbing, and other disciplines such as interior design or kitchen design. Some examples include solar, lighting, and sun studies within Revit. Choosing your site on the global internet mapping service, aligning that with your coordinate systems such as the Hartebeeshoek in South Africa, and choosing the correct weather system closest to your site increases the accuracy of your solar and sun studies for internal daylight factors with regards to SANS 10400 XA calculations and external sun penetration on the facades, which aid solar panels to generate operational energy for your buildings. All this can be done within Revit. Whether you're designing a home, office, or large commercial building, understanding how light interacts with your spaces is essential for creating energy efficient and sustainable design. When you run a solar study, you have your sun settings. You can select a single day, a multi-day study type. Your specific site data and geolocation are set, whether you're acquiring the data from Civil 3D coordinates or placing it in Revit. These are based on real-world accurate weathering data. So see how the sun and shadows interact with your building at specific times of the day. This was an example of 12th December in Cape Town from 5:33 a.m. till 19:46 p.m. Additional to the sun study via the graphics panel, Insight in Revit includes tools to analyze solar exposure and shading effects, helping architects optimize the building's layout and orientation for solar gain or shading as needed. By performing the solar studies, designers can determine the ideal window placement or shading strategies that help control heat gain in warmer climates and capture solar warmth in cooler areas. This analysis aids in designing facades and shading elements that effectively manage sunlight, improving energy performance and thermal comfort. Then the Insight Lighting Analysis tool is also available to quantify light levels. This tool evaluates lux levels, measuring how much natural light a space receives. For sustainable design, achieving adequate daylight without glare is key. The lighting analysis, especially in Autodesk Revit, is a simulation process that helps designers evaluate how natural and artificial light behaves in their design models. The goal is to measure the light levels inside spaces, helping architects and engineers optimize building performance and improve the occupant's comfort. So once the external sun study has been done, open an internal perspective and see how the sun would light up the rooms and interact with your space. To determine the need for artificial lights, understanding the demand for operational energy. Once the solar and sun studies have been done, architects and engineers will have a better understanding of the energy or electricity required to optimize the livability of the solar spaces, of the internal spaces and the entire structure. Solar studies can determine how much sunlight your site receives annually to generate solar power, seeing how much light penetrates the building, what the temperatures will be like, can be determined with the use of Autodesk Forma with regards to daylight factors and the microclimate information that we saw earlier in the webinar. All of these analyses are available to improve sustainable architecture for a greener future. Understanding that with regards to your wind as well, understanding what the ventilation will be like is ideal for window placement and understanding your shadows and sun. So BIM Collaborate Pro for cloud collaboration. Autodesk's vision for a sustainable future isn't just about powerful analysis tools, it's also about how we work together. So that's where the BIM Collaborate Pro comes in. Where we start in Autodesk Forma, where we can run early stage studies on energy, solar and carbon. The data doesn't stay siloed, it flows seamlessly into Revit. Where detailed design happens, Revit models can be cloud hosted, meaning that the architects, engineers, consultants, contractors, subcontractors, project teams, shareholders, stakeholders, all can collaborate in real time without the hassle of file transfers, printing papers, having in-person meetings, this resulting in risks such as version conflicts and more. From there, the model can connect into Civil 3D, AutoCAD, Navisworks, or the other Autodesk tools, ensuring that the infrastructure, the detailing, which we saw Revit can do, and clash detection with Navisworks or within the BIM Collaborate Pro environment are part of the same workflow. But all of this happens in BIM Collaborate Pro, giving the entire project team a single source of truth. The lifecycle approach from concept in Forma to design in Revit to construction coordination in Navisworks allows us to make smarter, more sustainable decisions earlier, reducing waste, rework, and carbon impact across the project. It's about designing better together and keeping sustainability at the heart of collaboration. So BIM and sustainable design. BIM means data-rich models that inform sustainable decisions. BIM gives us more than just a 3D model. It gives us data we can use to evaluate and improve sustainability. Every object can carry information about the energy use, the material impact, the life cycle cost, and more. Early stage design analysis with Autodesk Insight and Forma. So with Insight, we can evaluate energy performance and daylighting before the construction begins. We can make design decisions, changes that significantly improve efficiency with just a few early decisions. Tracking the energy use and the carbon footprint in Revit. Revit allows us to visualize and quantify the energy consumption and the embodied carbon of different design options. This helps the team choose the most sustainable solutions. So collaborative design means smarter resource use. Sustainability is a team effort. BIM allows the architects, engineers, and consultants to work on the same model at the same time wherever you are globally. To reduce the waste and avoiding rework, everybody works on a single source of truth. You see the same model with the same information, the same data is shared with everybody. This allows for better decisions early in the project's life cycle. The earlier we integrate sustainability analysis, the more impact we can have. BIM gives us the tools to test ideas quickly and implement smarter strategies before they cost more later. Revit can use the data that has been applied through parameters applied to the different materials. Sustainable design in action. So BIM is more than the 3D visuals. It's a data-rich environment for smarter decision making. Every model element can carry key performance data from energy use to the lifecycle cost. Revit computes electrical loads, water usage, airflow, and operational energy from the family data. Plumbing, HVAC, lighting, and ventilation can all be analyzed directly within the model. Generative design in Revit helps optimize window placement and building ventilation. BIM enables simulation, analysis, and sustainability planning far beyond traditional modeling tools. So how do we meet the demands of sustainability, speed, and team alignment? This is where the Autodesk AEC collection becomes essential. Rather than a single app trying to do everything, it offers an integrated ecosystem of powerful tools that work together. From the conceptual analysis in Forma, detailed design in Revit, and performance evaluations with Insight, to full collaboration and coordination using the BIM Collaborate Pro. Everything is connected and everything is purpose-built for the AEC professionals. The result? Smarter decisions, faster delivery, and more sustainable outcomes across the project's lifecycle. So Revit is for model smarter, design better, document efficiently. Forma, analyze the environmental impacts from the earliest stages. Insight, real-time energy and performance simulation tools. Civil 3D, design the site and infrastructure with precision. BIM Collaborate Pro, cloud collaboration with integrated issue tracking and clash detection. Autodesk Docs for your centralized document management for every team member. So in conclusion, repetition is key, right? BIM empowers informed, eco-conscious decisions. We've seen how BIM isn't just about 3D models. It's about making smarter, sustainable choices grounded in data and performance insights. Early integration leads to greater impact. Tools like Revit and Insight are most powerful when used early in the design process, when decisions carry the most weight for the long-term sustainability. Collaboration tools reduces waste and errors. So the Autodesk Construction Cloud and BIM Collaborate Pro foster a connected ecosystem where the teams can coordinate better, avoid mistakes, and streamline delivery, saving time, cost, and carbon. Data-driven design supports long-term performance. From life cycle assessments to as-built models, Autodesk tools equips teams to design not just for today, but for decades of efficient operation and minimal environmental impact. So let's build with the future in mind. Every building we design is a legacy. BIM gives us the tools to make the legacy sustainable, responsible, and resilient. So as a final thought, the greenest building isn't just the one that looks sustainable, it's the one that was designed with intention, measured by data, and built to last. What legacy will your next project leave behind? If you have any questions, please do not hesitate to contact us here at Micrographics. I hope you found this webinar informative. If you haven't subscribed, please do so, and don't forget to like and hit that notification bell for future webinars. Thank you again, and goodbye.